Rocks, rocks, and more rocks. Let's take a look at the three main types of rocks. Igneous rocks, which are born of fire. Sedimentary rocks, which many come from sediments called clasts. And metamorphic rocks, which come from heat and pressure. Kind of like the weight of the world pressing down on you. So up first will be igneous rocks, derived from a Greek word for fire. Igneous rocks form from hot molten rock that cools and then solidifies. Igneous rocks may form from magma, which is found inside the earth, or lava, which is molten rock on the surface of the earth. There are two major types of igneous rocks, intrusive and extrusive. Let's take a look at how intrusive and extrusive rocks differ in terms of what they form from, where they are created, the rate of cooling, the size of crystals, and the texture. Extrusive igneous rocks are created from lava. Lava is molten rock found on the surface. Intrusive rocks are created from magma, which is molten rock found inside the earth. Extrusive rocks are created on the surface where molten rock has flowed. Intrusive rocks are created inside the earth from hot magma. Extrusive rocks cool quickly. Intrusive rocks cool slowly. They're inside the earth, which acts a little bit like an oven, which slows the rate of cooling. Extrusive rocks may have really small crystals, smaller than 1 millimeter, or no crystals at all. Sometimes they may either be vesicular, which means the rock may have air bubbles. Intrusive rocks have crystals larger than 1 millimeter. Take a look at these intrusive rocks and their crystals. Extrusive rocks have a very fine texture. Some, like obsidian, may even be smooth. Intrusive rocks have a coarse texture, which can be described as rough. Because intrusive rocks have larger crystals, this makes their texture rough. See if you can tell if the following rocks are extrusive or intrusive. Another way that you can classify igneous rocks is to determine if the rock is mafic or felsic. Classifying as mafic or felsic is actually a scale of the percent of silica found in the rock. 0 to 45% is considered mafic, and 65% or greater of silica is felsic. 45 to 65% is considered intermediate. Mafic rocks are dark in color, and felsic rocks are lighter in color. The names give you a clue as to what other minerals make up these rocks. Mafic can be broken down into Ma for magnesium, and then Fic, which is Latin for iron. Felsic can be broken down into Fel for feldspar, and Sic for silica. Let's take a look at some mafic and felsic igneous rocks. Let's take a look at metamorphic rocks. This classic building contains a metamorphic rock called marble. Rocks are classified by how they are formed. Metamorphic rocks come from existing rocks that are subjected to extreme heat and pressure. Metamorphic rocks are created when extreme heat and pressure changes the original rock into a new type of rock. Sedimentary, metamorphic, and even igneous rocks can all become new metamorphic rocks when exposed to heat and pressure. The original rock is referred to as the protolith, but it's commonly referred to as the parent rock. Contact metamorphism occurs when existing rock comes into contact with extreme heat, like magma found inside the earth. Kind of like when this toast is exposed to heat inside the toaster and is changed. Regional metamorphism is caused by extreme pressure. The pressure presses and squeezes the rock and transforms it into something new. Kind of like this gravity acts on the balloon and transforms its shape. This often occurs at convergent plate boundaries. Existing rocks are transferred into new rock at these boundaries. Two major types of metamorphic rocks are foliated rocks, which have layers or bands, and non-foliated rocks, which do not have these layers or bands. Here's a common example of metamorphic rocks. Shale morphs into slate, which morphs into phyllite, which transfers into schist that can morph into gneiss. Another common example, sandstone, when exposed to heat or pressure, morphs into quartzite, and this limestone will morph into marble. Now let's take a look at sedimentary rocks. This rock wall is an example of sedimentary rock. Sedimentary rocks are derived from igneous, sedimentary, and metamorphic rocks. Sedimentary rocks make up around 75% of the rocks on the Earth's surface. Let's take a look at how clastic sedimentary rocks form. Clastic sedimentary rocks are the group of rocks most people think of when they hear the term sedimentary rocks. Clastic sedimentary rocks are made up of pieces of pre-existing rocks called clasts that vary in size. These sedimentary rocks follow WEDCC in order to form, which stands for weathering, erosion, deposition, compaction, and cementation. Weathering is when pre-existing rocks are broken down. This may occur by freezing and thawing of water inside the cracks of rocks, trees and other plants growing into cracks, and even blowing winds. Next, you have erosion, which occurs when these clasts or pieces of rocks are created during weathering and then are transported by either wind, water, or even gravity to a new location. Deposition is when the particles are deposited as loose sediment. Usually this is near a body of water, but not always. Over time, compaction occurs as layers of deposition build on top of one another and begin to squeeze together. Cementation occurs eventually when the minerals in the water will act like glue and cement all the pieces together. The end result is a sedimentary rock. This process of loose sediment hardening into rock by cementation and compaction collectively is called lithification. Moo Math uploads a new math and science video every day. Please subscribe and share.